15, 19, 18, and 9 in the chat, and I've already videoed, what did I say, 12 and 14. So if you guys need those, we've kind of got those done. There is some extra noise today. Not only is the gardener here, the house painter, and I have the 2 little babies at home. So I apologize for the extra noise, but we'll see what we can get done in the next like 25 minutes-ish, okay? So entire screen. All right. Okay, so we're going to start with, Erica wanted 6 and 7. So let's start up at 6 and 7. And I know I just kind of grabbed the PDF file, so it kind of looks crazy. So I apologize that it looks crazy. All right, so we've got to do second derivative of this y equals cosecant x over 2. So this is very deceiving in the way that it's written. I would totally rewrite this as y equals 1/2 cosecant x. Hopefully that makes it look a little bit better. And it says that we are going to need to use a trig identity to actually get that final answer, which I might not put something quite that tricky on the test, but again, this is kind of the general review of this chapter. So you never know. But I might not get quite that tricky on the test. But it helps our brain stretch. So tell me out in the chat, what is the derivative of cosecant of x? As you're doing that, remember that you are allowed to have your notes out during the test. If it was me, I would start a running page of like, what are all my derivatives and what are some of the derivative rules, and make that like into a single page. Still waiting. Does anybody know the derivative cosecant of x? Good job, Erica. Good job, Noelle. Okay, so a little bit, Erica, I want you to look at the other 2 answers, okay? And notice that you just missed the negative in front. So if we're taking the derivative of something that starts with a C, we know we have to put a negative in front of it. That's kind of the rule. But good job, you got the cosecant cotangent part. So we've got negative cosecant x cotangent x. All right, so now we have to take the derivative again because it said it wanted us to go to second derivative. So you'll notice that we have a product rule now. We have this times this. So I've got to use a product rule to get to the next derivative. So we'll blue again. So y prime equals the derivative of the red. So you guys just told me that the derivative of cosecant is negative cosecant x cotangent x. And then we do the original green, and then we use a plus sign, and then we do the original red, which is negative 1/2 cosecant x, and then we take the derivative of cotangent. The derivative of cotangent should be cosecant squared x. Okay, I'll give you a second to catch that up. All right, now I am going to do some factoring out before I try to do anything else, okay? I am noticing that I have a cosecant here and a cosecant here and the 1/2. So I'm going to pull those out as well. And I'm going to pull out a negative 1/2, it looks like, okay? What happened here? Negative, yeah. Let's pull out, actually, no, I'm not. I'm going to leave it as just a 1/2, not a negative 1/2, because this 1/2 right here technically goes positive. So I'm just going to pull out positive 1/2. I'm looking at the signs on the notes I have here. So, all right. So let's factor, and this should have been double derivative. So we're going to factor out 1/2 cosecant x. So left behind, I technically have cotangent times cotangent, so that would be cotangent squared x. And then this here would be, we still have the minus sign in front there, so minus cosecant squared x. So I want you to think back to the beginning of the year. And we have the Pythagorean identities, okay? the Pythagorean identities we could rearrange, okay? So one of our Pythagorean identities was 1 plus the cotangent squared x equals the cosecant squared x, okay? So I could take and subtract this to the right side, which would give me cotangent squared x minus cosecant squared x. And I can subtract the 1 to the other side, so it equals -1. Hopefully you're noticing that this is the same as this. So I can substitute the -1 in. Okay? And the reason this would be important is because if I was just doing this and it was open-ended question, absolutely 100% stop here, okay? But if this was a multiple choice question, we would probably have to keep going. So if you do the problem and you don't see your answer, you're probably gonna have to do a little bit more. So we would end up with a final answer of -1/2 cosecant x. All right, well, you're writing down. I'm going to see what the next one on our list was. I do like doing this questions in the chat thing because I can actually go back and see I don't forget what questions we needed to do. All right, we're going to do number 7 next. Are we all okay on that one? All right, thank you for the feedback, Jocelyn. All right, let's take a look at number 7. And I did give you a little hint. When it comes to the AP test, this one's kind of rare and unique. It's like it would pop up as like maybe one multiple choice question. But the hint is that you're going to probably have to apply your log rules first. Okay. So I know that when we are multiplying, I switch to addition, and when we are dividing, I switch to subtraction. Okay. So I'm going to do that and see if I can squish it into here. So this would be the natural log, h of x. H of x equals the natural log of x plus the natural log, I'm going to erase this here, the natural log of x minus 1 cubed minus the natural log of the square root of x minus 2. Okay. Then, I'm looking, there we are. I know that another rule, actually I'm going to rewrite this guy a little differently. Instead of writing that, I'm going to write it to the 1/2 power. And that's something that should be getting a little bit more automatic. When you see that square root, you know that you should be able to easily convert in your head that it's the 1/2 power. All right, our other rule that we have with logs is that if we have an exponent, we are allowed to move that exponent out in front, which should make our life a little bit easier. So we've got the natural log of x plus 3 natural log of x minus 1 minus 1/2 natural log of x minus 2. All right, the good news is if we look at all of our chain rules in here, all of my u's would be x minus 1 would come out to just be a 1, right? So I really don't need to do the chain rule piece, okay? I'm just going to kind of ignore the chain rule because it's just a coefficient of 1 in front. All right, so when I take the derivative of natural log of x, help me out and tell me what's the derivative of natural log of x. Excellent, Marissa and Noelle and Jocelyn. Good job. It's 1/x. Plus, this is just going to be a 3 in the numerator, and it's whatever's inside here, we put it over on the bottom, right? So over the mess. Minus, this 2 is going to hang out in the denominator. We have a 1 in the top, and then parentheses x minus the mess. And you'll notice I didn't even distribute that in the answer. It's frequent that they might not do that. Okay? That one was nice. That one was a lot better than the last one, huh? Definitely better than what we saw during second period. All right, 15 and 19 is where I'm going to head next. All right, so 15, I'm 10, 11, 12, 13, 14, let's see. It looks like, oh, I didn't even finish. It looks like I finished 14, huh? I'm gonna have to go back and do that. All right, I believe that this one is 15. Is that right? Is that one 15, ladies? Okay, perfect. All All right, and it looks like I've got, like, we might barely get through this one, okay? So we're going to ignore the fact that there's a graph there. It doesn't really have any bearing on the problem. They give us this stem, and they say, hey, find dy dx, which means that I need to do implicit differentiation, and it looks like we also have our friend, the product rule, hanging out in there. So that's what we're going to do first to find dy dx. So the derivative, I'm going to do this in blue. The derivative of 2x would be 2x, so x squared would be 2x dx dx, but again, the dx dx is just 1, so I'm going to get rid of it. Then I got to do the derivative of the red, which would be 1 dx dx, and I did that in pink, didn't I? Which I'm going to just get rid of because it is just 1. Keep the green the way it is. Put a plus sign. Keep the red the way it is. Take the derivative of the green, which would be 1 dy dx, plus the derivative of y squared would be 2y dy dx, and the derivative of 1 would be 0. All right, we're going to get all the dy dx's on the left and everything else on the right. So we've got x dy dx plus 2y dy dx, keeping that there. I'm going to subtract the 2 and subtract the 1. So negative 2x minus y. Factor out the dy dx. I'm left with x plus 2y equals negative 2x minus y. And we're going to divide the mess to the other side, right? So we've got dy dx equals negative 2x minus y over x plus 2y. I'm going to give you a minute there. All right, so now we need to find all the points on the curve where the tangent line is parallel to the line y equals negative 2x. So if I am parallel, what does that mean about the slopes? What does that mean about the slopes if I am parallel? Good job. They're going to have the same slope, okay? So that means, so parallel, I'm going to write that in there. Same slope for all of our friends who did not join us. So I know that my slope has to be equal to this guy right here, okay? So we're going to do that negative 2x minus y over x plus 2y equals negative 2, because I really only want the number that's the slope number because they're parallel. All right, now the catch is we have to figure out, which I don't have my notes in front of me, but all the points occur tangent to the parallel line. Type in the smaller value first. We need to be able to get the, oh, I wonder if that's where that picture comes in. But I can't really read it off the picture, can I? All right, ladies, what I'm going to do, because I don't want to waste time and I want to get through as many as I can, I'm going to put a pause on this one. I'm going to put like triple stars by it. I need to go look at my notes, which I didn't grab out of the other room, okay? So give me a pause on that one, and I will come back to it. We'll definitely do it this afternoon if you guys want to come back this afternoon. If not, we'll definitely get to it tomorrow morning, okay? So let's look at, so I'm going to skip the rest of 15. We'll come back to it. Let's look and see what 19 says. All right, so that was 15. This is 16, 17, 18, and 19. Do I have the right problem for 19? Okay, go watch the movie, dude. All right, perfect. Okay, so we need to find the derivative of arcsine of x minus 2x, okay? Literally all you're doing is applying the formula. So again, you want to make sure, I would have that list of formulas. I would not be trying to flip through my notes. So make yourself a one-pager, okay? That's a really helpful, handy thing to do. All right, so arc sine, literally applying the formula f prime of x equals. So arc sine is, we always have the u. The u is this part though, so which is just a 1, so I'm just going to go with 1. And then that's the one that goes square root of, if I did the actual like formula, it's 1 over the square root of a squared minus u squared. So my a is the number in the bottom, which is a 1. 1 squared is 1, and then minus x squared is the variable on the top. And then the derivative of negative 2x would just be negative 2. That one was nice, right? We wouldn't, even though that's an inverse trig, we wouldn't mind that one on the test probably, because it was kind of a nice one. All right, let's look at 18. I'm going to pop up to the next one here.
Can we? Oh, never mind.
Yeah, go ahead, Marilyn, go ahead.
Can we do the rest of 19, like part B?
Oh, is there a part B? I missed part B. I'm sorry. Thank you for pointing that out. Okay, I didn't scroll down. All right, so we got to do equation tangent line. Thank you for stopping me. So equation tangent line, 2 things we need, point and slope, right? They tell us the x value. So I've got 0, comma something. My y value I've got to take and I've got to plug into this. And that's probably the ugly part, right? Because I've got to plug into the arc sine. So f of 0 equals the arc sine of 0 minus 2 times 0. All right, so we got to think about, this is talking about 0 radians. Okay, so I need to figure out what the crazy x value is at 0 radians. Okay, so 0 radians is here. Sorry, not the x value, but the y value. So we know that cosine is first, sine is second. So the y value is 0. So I get 0 minus 0, which is just 0. So I have the point 0, 0 for my tangent line. And then to get my slope, I'm going to plug into our answer that we got up here. Okay, so we're going to do f prime of 0 equals 1 over the square root of 1 minus 0 squared minus 2. And then let's see, so that's going to be 1 minus 0 is 1, square root of 1 is 1. So 1 over 1 is 1 minus 2, which is going to give me negative 1. So I've got my point, I've got my slope, I am ready to write the equation of my tangent line. So I'm going to do that kind of right here. So y minus 0 equals my slope negative 1 times x minus 0. If I got rid of all my zeros, I would just be at y equals negative x. Are you doing okay there, kiddo? Yeah, you guys hear the baby laughs? Baby laughs are good, huh? He's not really a baby anymore, but he's my baby. Yeah, you can go play with the car. Chew your popcorn and go play with the car. Popcorn before lunch is always a good idea, right? All right, let's pop up to 18, ladies, okay? All right, so here's 18. It looks like this one's a little bit crazier than the last one. So I'm seeing a product rule, but this product rule also has a chain inside of it, okay? So I'm going to follow my rules. So f prime of x equals, I take the derivative of the red, which would be 2x. I keep the green the way it is, arctangent of 5x. And then I'm going to add that to the red the way it is. Look at how long I was able to avoid that chain rule, right? So I'm going to do my chain rule work kind of off to the side here. So I know that for the green, my original would be arctangent of 5x, which I'm just going to say is y equals. And I'm going to go with my u, which is 5x. So u prime is just going to be 5. And then we're going to do the derivative, or I'm going to replace, right, arctangent of u. And now I'm going to do derivative. So derivative of arctangent is 1 over 1 plus, so this is the a again, so a squared plus u squared, or as it is backwards. Let's see. Nope, they did it that way. Okay, and then we're going to take and multiply that by the derivative of the inside, which is just 5. And then I'm going to do some replacing. I'm going to go ahead and just do my replacement and pop it here. So it looks like I have a 5 in the numerator. And then my denominator will be 1 plus the u, which is going to be 5x squared. And then I can clean that line up just a little bit. So f prime of x equals 2x arctangent of 5x. My numerator is going to be 5x squared over, and then when I square this, I get 1 plus 25x squared. And ladies, I think I'm going to stop it there. I know some of you still had questions. Okay, so I will be back this afternoon. I'll send out a link again, and we'll do this about 2:35 to 2:45. I'll start, and I can probably stay till 3:15, 3:30 today, and we'll probably be able to knock off a whole bunch more of them, okay? So I will see some of you later. If not, I will see you guys tomorrow, and we'll knock off some more of them in class tomorrow. You're welcome, ladies. Thank you guys for coming and being an audience. You're welcome, Noelle and Marissa, Erica.
You're welcome.